An elevator starts from rest and travels up a 400 meter tall building. And we can make the following assumptions for the coasting speed and the acceleration and deceleration. And now we can choose our coordinate system with the origin at the starting point of the elevator and a positive direction upwards. So here we have a time of t equals 0, and we break this up into 3 intervals of motion because the acceleration changes. So to find the total time taken for the elevator to reach the top of the building, we can find the change in time in each interval. So in the first interval, we can use this kinematic equation. So this is the same as t1 minus 0, which is equal to delta t1. And by symmetry, that's equal to delta t3, which is t3 minus t2. Now to find delta t2, we can use the height of the building, which is equal to the sum of the distances travelled in each interval. So to find delta y1, which is equal to y1 minus y0, we can use this kinematic equation, because we've already found delta t1. And by symmetry, delta y3 is y3 minus y2, which is equal to delta y1. And from this equation, we can find delta y2 and substitute it into this equation with the coasting velocity being constant. And that gives you delta t2. And we can sum these up to get the total time. So post your answer in the comments.